Hello everyone, welcome back to another daily Leetcode challenge. So today we will be solving a problem, range product queries of power. So we are given a positive integer n, and we also given another 2D array, which is the query that has a left and right boundaries. And the goal is to return an array answer that equal to len in queries, where answer is the answer of I query. Since the answer may be too large, we want to return it in a modulo of 10 power 9 plus 7. So for example here, the example one, we have input n equal to 15, and the queries has a 0, 1, 2, 2, and 0, 3, and the output is 2, 4, and 64. So how can we get this output? So let's have a look at the drawing board and see if we can try to understand the problem first. Now let's have a look at a simple example here. Let's say we are given an integer n of 5 and a range of queries. So the idea is to convert this n integer into a binary representation, and it can be written as 1, 0, 0, 1, and this means we will get something like this. So since it's binary representation is 1, 0, 1, so we get like 1 times 2 power 0 plus 0 times 2 to the power 1. It's because the second digit here is 0. So, and then we add 1 times 2 to the power of 2. So if we sum all of this, at the end we will get 5, which is the integer n itself. So that means we get a list that would be looking something like this. So because this is 1 and this one is 0, so we're not gonna include it in the list. And this one is non-zero, so we will include it in the list, so which is 4, right? So now we get this list. That means we are ready to compute the queries here. Okay, so let's take the first query, which is range from 0 until 1. So since we have 1 and 4 in our list, so we want to compute product from this left boundary all the way until right. So we have two numbers. That means we will have 1 multiplied by 4. So the first query, which is Q1, will be equal to 4. Now for the second query, the range is on the left is from 1 until 1 itself. So that means we only need to return this value since it's only the one that cover the window for the second query. So that means the second queries will be equal to 4. Yeah. So yeah, that's how we kind of like come up with a brute force approach to solve this problem. So first we want to do is to convert the n integer itself into a binary representation and get a list of those number. And then in each query, we process it one by one, and we do another loop from left to right, and then take all of this value inside the binary representation and sum all of them, and then we append it to, maybe you can call it the answer list, and then you add it one by one. So the time complexity of this brute force approach is roughly O of log n. Log n is when you convert the n integer into a binary representation, and you also plus O of m, where m is len of the query. Yeah. Now, there's a way that we can solve it in an optimal way because, you know, you don't want to recompute it every time. For example, you recompute this one from 0 to 1, and then you compute 1 again right here, which is redundant. So that means you can kind of like cache it. So let me show you how we can solve it in an optimal way. All right. So now how do we go about solving it in an optimal way? So to solve it in an optimal way, you need to understand the idea of prefix sum. But this time we are not doing sum, we are doing product instead. So I'll call it prefix products or whatever. So the idea is let's say in this example, I want to have n as equal to 15, and the representation of n would be looking something like this, like you see in the problem description. So we have 1, 2, 4, and 8. So now I want to create another list which called prods, which is all the products of the range from the left all the way to the right. Why it has one by default? I'll show you why there is one by default. So now let's just compute all the prefix products by taking each value in the representation here. So we take one right here, and then time the previous value inside the prod, we get 1, and now 2 will multiply the previous value inside the prod. Now we get 2. Now 4 will multiplies the previous product in prods. Now we get 8, and 8 here will multiply previous value in prods. We will get 64. Now our prefix products is ready. You can start processing the query. So for example, let's have a look from the first one. So we have 0 to 1. That means, okay, let me just write out the index. So remember that the first query, what we get back is, I think it's 2. So let me find a way to write here. So the query 1 is 2. That's because we take in the representation we take this value times this value. So how do we use that idea inside our pre-computed products? So now we need because like the right boundary is 1, but in here you kind of like offset it by 1 because there is a value here 1 by default, so you offset it by 1. So now your right boundary will be this 2, and your left boundary will be 0 here. So that means you only need to return this value and then divide it by this value, which gives you 2. Okay, so now let's have a look at another query, which is query 2. So the query 2 would I guess it should be from this value all the way, no, sorry, it should be returning back 4. So in our pre-compute products, we'll take the value at r plus 1, which is 2 plus 1, that is 3. So we will get 8 here, and then divide it by the left, which is 2. So 8 divided by 2, you'll get 4. So this is the value that we'll add into our final list. So I hope you get kind of get the idea of this pre-compute products. So it's kind of save time. So I think it's the time complexity of this would be all log n. So log n is still here because you need to turn an integer into binary representation. And the yeah, for the pre-compute products here, so that means you only kind of like yeah, it's just O of m, which is the length of the queries. Yeah. So I hope you get the idea here, and let's get into the coding part. So now let's get into the coding. So in this demo, I'll only show you the optimal solution, but if you need to look at the naive solution, I'll just link it in the video description, and you can click on it and you will see my solution on Leetcode. So, right, so the first thing that I want to do, if I want to create a list which called a bin representation, that will be the value of um, the binary representation of n. So I also want to create another variable called mod because we want to return the value by taking the modulo of 10 power 9 plus 7. Now, starting with rep of 1, I'll just do a while n is equal to 0. I'll check this um, if this digit is 1, I'll just add it to the binary representations. And then I'll just divide n by 2. If you don't understand this code, I highly suggest you solve the I believe there's a problem in Leetcode where you can convert the um, you know decimal number or decimal number into a binary representation. So you will know how to just write this code up here. Yeah. So next, I'll just create a list that store my answer. And I'll just create another list called, this is for pre-computed prods. It's that default by 1. And I'll just create another variable called prod that is for, um, taking all the product and then sum all of them. So now for rep in our binary representation, I will add a product to the previous product, like add them up and then append it to the list pre-computed list. And I think now you can start processing the query. So I'll take 11 right boundary in the query, and the answer would be prod of left plus left itself. No, sorry, it should be or plus 1. Remember that we are offsetted by 1 here because there are value in 1 in it by default, and I just divided by prods of the left boundary. And one other thing, you don't need to you don't forget to mod modulo by this mod here. Otherwise, you will get wrong answer in some test cases. And now you can return back the answer. And let's try and run the code and see if it passed the interim test cases. All right, so let's run all the test cases. Cool, now it passed all the test cases. So yeah, that's pretty much it for optimal solution. I'll just link this both of the optimal and naive approach naive solution in my video description. I hope you like it. If you have any question, please add it to the comment. And otherwise, I'll see you in the next daily challenge. Thank you so much.